Welcome to this explainer. Look, if you're an absolute beginner to coding, you are in exactly the right place. Today, we're demystifying Unit 2 of your problem-solving technique course, specifically C programming. We're going to keep things super light, but detailed enough so you can easily follow every single concept. And to make it totally real, we'll be building your very first C program from scratch, step by step, by capturing and grading a student's marks. Let's get to it. Okay, here's our roadmap. We're going to hit Getting Started, Variables and Operators, Input and Output, Selection Statements, Control Structures, and finally, Pointers and Arrays. We're taking this step by step so you can see exactly how a logical thought transforms into actual running code.
Section 1. Getting Started. We're talking about the basic skeleton of your code.
We're starting with a totally blank canvas. The very first thing you're going to see at the top of a C file is something called a preprocessor directive. It usually looks like a hashtag, then the word include, followed by studio.h in brackets. Now, don't let that jargon intimidate you. Just think of this include line as opening up your toolbox before you start working. It just tells the computer to pull in standard tools, like the ability to print text out, before it runs any of your actual code.
Every single C program needs a heart, and that is the main function. You'll write it out as int main void, followed by curly braces. This is the mandatory entry point. It's literally where your program wakes up and starts executing. Inside those braces, we have a simple command called printf to print a student's mark out to the screen, followed by a return 0, which is just a nice way to signal to the computer that, hey, everything finished successfully.
Section 2. Variables, Operators, and Expressions. Let's get into math and memory.
So, now that we have our skeleton, we need to give our program some actual data to work with, like a student's marks. Think of a variable as a little labeled box in the computer's memory. But before you put anything inside, C needs to know exactly what shape of box to use. We call these data types. An int is used for whole integer numbers, like a mark of 78. A float is used for decimals, like an average of 65.8. And a char is for a single character or letter, like a grade of B.
Once we have our numbers safely in their boxes, we can do some math. C uses the standard everyday math symbols for addition, subtraction, multiplication, and division. But pay really close attention to the percent sign. In C, that is the modulo operator. It does not calculate a percentage. Instead, it gives you the remainder after you do a division. It's a really special tool we'll use later on to do cool things, like peel individual digits off a larger number.
All right, watch out because there's a huge trap here that catches almost every beginner. If you want to compute the average of 3 integer marks, dividing by 3 seems totally logical, right? But here's the kicker. Dividing by a whole number in C chops off the decimal entirely. To get a true decimal average, you have to divide by 3.0. You've got to explicitly add that 0.0 if you want a precise float result.
Section 3. Input and Output. Let's start talking to the user.
Okay, so our program can do math, but right now it's basically just talking to itself. We want a conversation. To build that, we use printf to display a message on the screen, like asking enter marks. Then we use a new command, scanf, to literally wait for the user to type a number. It grabs that input and neatly stores it into our variable using an ampersand, which is also known as the address of operator. Finally, we can use printf again to reply, echoing the mark right back to them.
Section 4. Selection Statements. It's time to make some decisions.
Next up, we need our code to actually make decisions based on the exact mark the user just entered. Selection statements let your program choose a specific path. It boils your logic down to simple yes or no branches. A plain if statement gives you one single path. An if-else statement gives you a fork in the road. For instance, if the mark is 60 or above, print pass, else print fail. Pretty straightforward, right? And a nested if is just a decision inside another decision. Like if they passed, let's ask a second question, is their mark 85 or above? If yes, print pass with distinction.
But what if we're dealing with a whole bunch of different grades? That's where the cascading if-else-if ladder comes in. It smoothly drops the student's mark into the correct letter grade bucket by checking conditions from top to bottom. Once a condition is met, say a mark of 78 hits the greater than or equal to 75 rung, it assigns a grade B and then completely skips the rest of the ladder.
Now, ladders are fantastic, but they can get a little messy, which brings up a great question. What if we want to quickly select from a fixed menu of options instead of climbing down a ladder? Say we're just looking for specific, exact grade points, like a 4, a 3, or a 2.
That brings us to a much cleaner tool for specific matching, the switch statement. A switch statement is literally perfect for a menu. It jumps directly to the matching case. But, and this is absolutely crucial, a huge beginner rule, you must include a break statement at the very end of each case. If you forget the break, your code is going to accidentally fall right through into the next case, giving a student a B and a C, which makes no sense.
Section 5. Control Structures. How to repeat your code.
Okay, so we successfully graded one student, but come on, a real teacher grades dozens at a time. We need to repeat our code. Choosing the right loop to do this depends entirely on what you know in advance. If you know exactly how many times you want a loop, use a for loop. If you don't know the exact count, but you want to check a condition before you run the code, use a while loop. And if you need the loop to run at least once, like say showing a menu to a user before asking what they want, use a do while loop because that one actually checks the condition at the end.
Imagine a for loop in action here. We can easily loop exactly 5 times through 5 student marks to find a total sum. But what if we're searching for a specific mark and we find it right away on the second try? We can actually use a break statement to hit the brakes early and exit the loop entirely, saving the computer a bunch of unnecessary work. You might also hear about something called the continue statement. That one just skips the rest of a single loop pass, but keeps the overall loop running.
Section 6. Pointers and Arrays. Organizing all that data.
In this final section, we're going to gently introduce pointers. Now, a pointer is simply a variable that stores the memory address of another variable. I know, pointers can sound super intimidating to absolute beginners, but just think of them like this. Instead of giving the computer the actual data, you're just giving it the street address of where that data lives. It's incredibly useful when you want different parts of your program to all modify the exact same original piece of data.
Also, instead of creating 50 separate variables for 50 different students, we use arrays. A one-dimensional array is basically just a neat row of marks, and you access each one by an index number. A two-dimensional array is more like a grid of numbers. Think of a spreadsheet. We can even use something called structures. These let you group completely different data types, like a student's text name, their integer mark, and their character grade, all bundled together. It's like magic, transforming scattered data into one complete, perfectly organized student record.
And just to plant a tiny seed for your future coding adventures, I want to briefly mention command line arguments. Sometimes you might see that main function written with argc and argv inside the parentheses. This is a slightly advanced topic, but it basically just means you can pass information directly into your program the exact second you run it, before it even has a chance to ask you for input. Which brings us to our final thought for today. Now that you know how to capture, grade, and organize a massive list of student marks in C, how on earth are we going to efficiently sort them? Well, you successfully built your very first C toolkit today, which leaves us perfectly set up to explore the totally fascinating world of sorting and searching algorithms in the next unit. So keep practicing those logic flows, have fun coding, and I will see you in the next explainer.